Hi, I'm Jerry from PressureWasher.net, Sirocco Vacuums, and Bulldog Pro Pressure Washers. This is one of our 12-volt burners. I'm going to show you how to change a burner nozzle and what to watch out for when you're doing it. There's a couple things here about this burner. If you didn't know what it's actually doing, there's a fuel pump and an electric motor. Electric motor drives the fuel pump. It also turns the fan, and it pressurizes the fuel, sprays it through an atomizing spray nozzle, and there's two high voltage electrodes here with a high voltage igniter back behind here that gives you the high voltage spark that ignites the fuel spray. And of course, with the right air mixture, it's supposed to burn nice and clean. We talk about the air mixture in a different video. That's the air band adjustment video. Anyway, changing the burner nozzle. First thing that we need to do is we need to access the interior, the electrode assembly or J-tube assembly. I'm going to show you in just a minute here. But first thing we want to do is we're going to take these two screws out of the top of this electrode, the high voltage transformer, and this thing hinges open. Oh, but wait, this one has a small problem, and I'm showing this for a reason. The springs are keeping this thing from open. I don't want to stretch the springs. They're not supposed to hang up like that, so I got to find out why. But I'm going to reach in here with the finger and just push the spring off the electrode. You'll see what's happening. So because the position of the electrodes is a little bit short and these weren't aimed quite up at it, these fell off the end and got hung up. We don't want them to do that. If this one falls off and gets hung up underneath here, the spark can actually short out against the J-tube underneath there, and you won't have any ignition. So it's really important that whenever you put these things on and off, you make sure that they don't get hung up. And if it does it once, it can do it again. So change something. Okay, so right now, what I'm going to change, since these pieces here are not long enough, basically, to keep this from hanging off. When I take the electrode assembly out, I'm gonna adjust those. I'm gonna bring those out about 1/4 of an inch. They're just screwed on, but they're screwed on too far. So I'm gonna fix the factory's mistake. Anyway, to get the electrode assembly out, I'm gonna use a small wrench, adjustable, and I'm gonna undo the copper fuel line coming from the fuel solenoid. That nut stays on the copper line just fine. It won't fall off. And there's a bulkhead nut right here that holds the J-tube in against the housing. So I'm going to loosen that nut very gently, spin that thing off of there. I'm going to let it rest on the copper line so I don't lose it. That way it can't fall off in the dirt or whatever. When you're in the middle of nowhere or the middle of the night, just put it over there on the copper tube and it'll stay there. Okay, now I want to bring your attention to this little screw connection right here. This little guy right here holds the plate, the adjustment plate for the in and out adjustment on the electrode assembly. If we move that electrode adjustment, then I want you to see right here that the position of the electrodes would be affected by that, because if it's too close to the shield right here, then it'll short out the electrodes and the spark will not be up against the fuel spray where it needs to be. And if it's too far back, you'll have a different shaped fireball. So this thing has to really be positioned exactly correctly. I'm going to hope that the manufacturer exactly set it where it needs to be, and I'm going to leave it there. Okay, and one thing that I like to do just in case something happens is I'm going to take a scribe. I'm going to use the tip of a screwdriver right now, and I'm going to scribe a little mark on each side of this so that anybody can see where it originally lived. If anybody accidentally moves it, we can say, okay, well, look for the little scratch, and if you see the scratch, make sure you position it back where the little scratch was. That's where it needs to be, and it'll be that setting for the rest of its life. Okay. I didn't see any problem with the position up here, so I'm not assuming that that's the reason that the springs were catching on the electrodes. I'll just fix the position of the tips over here and call it good. I don't want to change the setting on the in and out of the with the burner head. So anyway, I've got the copper line loose now, and that bulkhead nut is all that was holding the J-tube in. So I'm going to take this out. I'm going to with very lightly and gently, I'm going to twist this out and up. On a Beckett, these things come out pretty easily. On Waynes, because they've got a spring off to one side, they're a little bit harder to pull out, but you can jiggle them out. That's the way they work. And as you can see, this is the reason we call it a J-tube. And these are the high voltage electrodes, and they're insulators. When you're working on something that's been around, of course, this is not going to be bright and shiny clean. It's going to be all dirty and black because you had to take it apart for some reason. Probably needs to be adjusted. But when you go to clean these, use carburetor cleaner and take this thing and hold it over a trash can or at least some newspapers to catch what's coming off, because this black sooty stuff is really nasty stuff. It's actually carcinogenic, and you don't want it in your flower garden, so don't wash it off the edge of your driveway. Don't do this in the lawn. I mean, it's nasty stuff, but it has to go away easy and simple. So catch it in some newspaper and or do it over the trash can and let it go that way. But here's a magic trick. When you go to spray dirty, covered, sooty electrodes with carburetor cleaner, give it a quick shot, wait about 10 seconds, and then spray it again, and it'll just start dripping right off. Otherwise, you're going to waste those 10 seconds of carburetor cleaner unnecessarily. It has to penetrate before it starts rinsing. So you just spray, let it sit for a few seconds, little penetrating action going on, then it rinses right off. No big deal. It doesn't take much, and that's how you do it. The burner nozzle is this piece right here screwed into the end of the J-tube. I'm going to use a couple of wrenches to get this thing off. Sometimes they're really tight, sometimes they're not, but twisting your wrenches together gets them loose pretty easily. Not a big deal. Now this thing comes out, and you can see the filter. Okay, the filter protects the burner nozzle. If that filter is plugged, your nozzle will not flow the flow that it's supposed to. It won't spray the spray that it's supposed to, and you won't have a cone-shaped, perfectly misted spray, and it won't ignite properly. This is what causes white smoke and stuff like that. One of the things that can cause white smoke, I should say. Incorrect burn. You need exactly 100 psi or more in order for diesel fuel to atomize properly so that it can ignite properly. If your fuel pressure drops below 100 psi, you won't have ignition. It won't be reliable. That's a problem. Oh wait, that's why we have a fuel pressure gauge on here. If your fuel pump doesn't have a fuel pressure gauge on it, get it so you can maintain it, so you can check it, so you can troubleshoot it. If you want the rapid elimination of downtime, you have to be prepared. Electrical has to be easy to get to. The gauge has to be there where you can read it. The indicator lights need to be where they need to be. Otherwise, your downtime is going to take forever. You probably have to pay somebody else to fix it. I'd rather you fix it yourself with the understanding of how this thing works and how this stuff goes together. Anyway, while I have this out in my hand, we have a process procedure around here. Number one thing that we do is we take the number off the burner nozzle. This one is a 3.5. That's 3.5 gallons an hour, okay? And I put a piece of tape on the transformer here so anybody that opens this up can see what the nozzle size is. So this is a 3.50 by 90 degree. This is going in a big 20-inch heater, so this is a 3.50 by 80 degree burner nozzle. All right, so I don't have to take the whole J-tube out to go up or down in nozzle size. If there's something wrong, like the coil is all sooted up or something like that, and you need to go down to a smaller nozzle, how much smaller would that be? You need to know where you're at to know where you're going. So, or if you wanted more heat, or to know if it has the biggest burner nozzle that it can burn, you'd want to know what size it was. The biggest nozzle that you can burn in a 20-inch heater that has a big 10-inch stack on the top, not the horizontal with the little oval. Those don't burn as big a fire. A vertical heater that has the big 10-inch stack on it that can burn real easily with a big burner. You can burn a 3.5 burner nozzle and heat 8 gallons a minute to a full 200 degrees. This is a Beckett SDC burner. This is the bigger one. This one draws about 20 amps, 21 amps, I think it is, to run it. But if you want a lot of heat with an 8 gallon a minute machine, you're going to use a bigger burner, big burner nozzle, and you might even turn up the fuel pressure to 120 or so, depending on how high in altitude you are. If you guys are up in the mountains, you can't run the as big a fire because you're using more of your fan for pushing the extra air in that you need because you're at high altitude. And that reminds me, a lot of you guys, buy machines, off the shelf, and they just ship you whatever they made off the factory line, and then you get it up to, the Mile High in Denver, and all of a sudden it doesn't want to burn right. You got to open your air bands and adjust the air, and or back off the fuel pressure a little bit. Oh wait, you'd better have that fuel nozzle on. I mean the fuel pressure gauge on there. So you know what it is. But the point is that you need to be able to adjust it depending on altitude. And if you're going from, the Mile High Denver, also further up into the mountains, up into the resort area, you might have to be adjusting your air your air bands on your burner just to make it burn properly. On just going from one job site to the next job site. So be aware that you might have to do this. And your engine not running right at high altitude just indicates you need high altitude jets or buy a fuel injected engine. Anyway, back to the burner. This electrode assembly, while I have it out here, I want to show you the factory setting. The factory thinks that this is the setting that you want. The factory is a manufacturer of home heating burners. They happen to be used on pressure washers, but most of these burners go on home heating systems and for those portable heaters for warehouse use and outdoor use, like on ball fields and all that. Well, in a burner with a very small chamber, like a heater coil on a pressure washer, it acts a little bit differently, and we're going to adjust it a little bit tighter, and I'm going to show you how to do this. Two things. First of all, it's not real easy to bend these. They're hardened stainless steel, and this ceramic can break, and if we have any cracks or chips in the ceramic anywhere at any time, that ceramic is no good, and it has to be replaced because the high voltage will jump right through a little crack in a ceramic insulator. So anyway, I've inspected this. It's just like brand new, no big deal, and I'm going to try not to break it. So right now I'm going to loosen this screw that holds these things in place. Now I can move these. So what I want to do is I want to get that spark right up next to the high voltage spray. I mean the fuel spray with the high voltage. So I'm going to use my handy pliers and bend these in just a little bit. So I can get them up here closer and more personal with that high voltage spray. I'm going to tighten this up a little bit so they're not so loose. I don't want them to be too high because they'll hit that spray, that deflector that they go up against and short out. I don't want to do that. So I'm going to keep them down low, but I'm going to bring them in. Instead of having a 1/4 inch gap, we're going to go down to a 1/8 inch gap. And if you can imagine the fuel spray is coming out at a 90-degree angle, right now I'm right at the edge of that spray. That's exactly where I want it to be. I don't want it to be any farther away than that. Okay? I just want that high voltage to be right there up against the edge of that fuel spray, and I want the gap to be about 1/8 of an inch. And I'm awful particular, so I'm going to mess with this for a minute because I want it to be just right. And again, there's my 90-degree spray. I don't want to be in the spray. I'm a little bit too close right now. just like working on electrical, it's better to be patient and have it perfectly perfect instead of worrying about having a failure in the middle of the night when there's nobody else around to help you, having the right setting. I've got about 1/8 of an inch in between here, so they can't short out to the nozzle. They're about 1/8 of an inch apart. Okay, about 1/8 of an inch apart. Now I'm going to tighten that down, recheck it. And I don't, you know, you don't need to kill these things. We don't want to crack them. We just want them to be snug so they can't move. And you can tell the difference when you try to move them. Okay, that is right where I want it. So I'm going to give it just an extra little bit. Okay, not real hard, just enough to know that there's no way those things are moving. Because as you put this back in, they do bump around as you're going in, especially on a wane burner. They're hitting up against a couple things up inside there, and if it makes these out of adjustment, then now you've got an unreliable heater and you thought you got it right. Okay, so this is pretty snug. These are just the right setting. It's a much tighter spark setting than what came from the factory, but I'll tell you, you follow my lead, your burner adjustments will last 1.5 to 2 years instead of going bad in the 9th month. They want you to go to the service center and spend some money with their dealer. I don't want you to do that. I want you to make more money and buy more machines. So anyway, that's a nice adjustment. It's better than it was from the factory. I can text you an image of that. You can go to my website and check out the service information section and see a diagram of that setting. But anyway, so I'm going to put that nut back on the housing. Okay. Okay, make it finger tight, and then use your pliers to make it snug. It's not going anywhere. It's not going to fall off. The copper tube would hold it on even if it did get loose. So you don't have to kill it. You don't have to wear it out. You need to leave it serviceable for the next guy. Then you put the copper line back on. Again, it just needs to be snug. It needs to hold the pressure. It's a compression fit seal. You're not putting any Teflon tape on here. It's just a compression fit. But from the point that it mates, then give it an extra little nudge, and that's as tight as it needs to be. It's like spring-loaded, face against face. It's not going to leak. It's ready to go. Okay? Now, if you look at the end here, we've got the electrodes just right in the position where we're going to get a instant ignition. We can build a bigger fire because we can push more air into this thing, and the electrodes are going to ignite that fire. Okay, but they're still fairly far away from the shield, so we're not going to have any interruption with that. So this should be a very reliable burner for a long time. That's how you adjust the that's how you change the burner nozzle and adjust the electrodes. And back to putting this on, when you go to close this up, make sure that your wires are nice and neat. If they're not nice and neat, fix it. Because if they're not nice and neat and you go jamming them in there, you might pinch a wire, you might push a wire nut off, and besides, you don't know what's in there unless you check anyway. So, hey, why not check the wire nuts? Make sure that they're tightly tight, really tight. They're not gonna fall off, okay? I just put those on so I know they're nice and tight, but I'm showing you. This goes in here nice and neat. It all tucks in real nice, and I failed to adjust those pieces in there, but fortunately we can do it from the outside. So let's adjust those landings for the high voltage springs. So I'm just going to give these a turn. Okay, I'm also going to lean the springs upward a little bit. Just lean them upward a little bit. Okay, so they'll land right on there nice and neat. Let's make sure the wires are tucked in. No pinching. Okay, that lands on there really nice. And nope, they're still falling off. Okay, I'm going to pull this back out and move these out. This is an unusual problem, but at least we know what to do and we know why to do it. This has to be right, or it's not bulletproof. We build bulletproof systems. This ain't leaving until I get it adjusted perfect. Now you see what to do. If you want it right, or if you have any questions, call pressurewasher.net. If you have any comments, just see us down below there, and we'll be glad to help you. We make things last.